Good morning, dear students, and welcome back to our course. In the last lecture of this course, we discussed in detail about what will happen if we have a kind of passive element with us and when they are connected in series configuration or when they are connected in parallel configuration. And finally, we conclude that suppose if we have two resistors and when they are connected in series configuration, the effective resistance is going to be equal to the addition of individual resistance. So I can say that when the two resistors are connected in series combination, the effective resistance is going to be increased. In the same way, when we have two inductors and when they are connected in series configuration, the effective inductance is going to be the addition of individual inductance. So here I am considering that there will be no mutual inductance between these two inductor. So when two resistors or two inductors are connected in series configuration, the effective resistor or inductor is going to be increased. But this is not the case for capacitors. For example, if we have two or more than two capacitors and when they are connected in series configuration, the equivalent capacitance is going to be equal to C1 into C2 whole divided by C1 plus C2. That means the effective capacitance is going to be reduced when they are connected in series configuration. This is very important. On the other hand, if the capacitors are connected in parallel configuration, then what will happen? The effective capacitance is simply the addition of individual capacitance. So it will be going to be more as compared to the effective capacitance when they are connected in series configuration. So this points you have to remember. And then in the last lecture, we also discussed what is the meaning of mesh, what is the meaning of node, and what is the meaning of branch. So I told you that mesh is nothing but a smallest closed path available in a given circuit which cannot be further subdivided. And what is node? Node are simply a junctions or a point in a circuit or a network where we have a combination of two or more than two circuit element. It may possible that at node we have a combination of active and passive element. It may possible that we have a combination of different types of active element only, or it may possible that we have a combination of different types of passive elements only. The thing is that node are nothing but a point or a junction where two or more than two circuit elements are connected. And what is branch? Branch is nothing but simply a kind of elements which are available in a circuit. So to identify how many number of branches are there in a circuit, the thing is that we need to identify or we need to count how many number of elements are there in a circuit. It may possible that we may have a combination of active passive. The thing is that just we need to count how many number of elements are there. So number of elements are nothing but number of branches in a given circuit. And finally we write a mathematical equation between all these three parameters. We have written that mesh is equals to branch minus node plus 1. This is very important. So this is for all physical possible network. That means if you take any kind of network, this equation is applicable to them. Mesh are always going to be equal to b minus n plus 1, where m is mesh, b is branch, n is going to be equal to node. And then we discussed the most important circuit analysis tool as far as network theory is concerned, and those are nothing but Kirchhoff's laws. So what exactly Kirchhoff's laws tell us? That it is simply the applications of law of conservation of charge, which is nothing but Kirchhoff's current law, and second one is law of conservation of energy, which is also called as Kirchhoff's voltage law. Why Kirchhoff's voltage law is called as law of conservation of energy? Because we know that voltage is proportional to energy. Because if you see the fundamental definition of voltage or potential, it is simply energy per unit charge. That's why V proportional to E. In the same way, Kirchhoff's current law is also called as law of conservation of charge. Why? Because we know that current is proportional to Q. That's why when we are applying KCL, that means we are basically applying law of conservation of charge. And when we are applying KVL, that means we are applying law of conservation of energy. And I told you that while applying KVL or KCL, we need to take a proper sign convention. So what is this statement for Kirchhoff's current law? It is simply the algebraic sum of current approaching or leaving from a junction or at a node in a circuit is always going to be equal to 0. Condition is that we applied a negative sign convention, or you can say opposite sign conventions, to the input and the output current. For example, if you take input current or incoming current as positive, then in that case outgoing currents are going to be negative. Or if you take outgoing current as positive, then incoming current is going to be negative. In the same way, when we are dealing with Kirchhoff's voltage law, here we need to apply law of conservation of energy, and it simply states that in any circuit or in any network, that too within a closed path, the algebraic sum of voltages, that may be a combination of voltage drop and voltage rise, are always going to be 0. The thing is that we need to apply opposite sign conventions to them. That means if we take voltage rise as positive, then voltage drop is going to be negative. Or you can reverse them. If you take voltage rise as negative, then in that case voltage drop is going to be positive. But normally I prefer this sign convention to apply KVL in any circuit. Voltage rise is positive. That means when we are moving in the opposite direction of current, we will experience a voltage rise. And voltage drop is going to be negative. That means when we are moving in the same direction of current, we will experience a voltage drop. This is very important. And also in the last lecture, we saw some previous year gate numerical, which are based on dependent sources. For example, if we have dependent sources in a circuit, then how to solve those network. So we have solved some previous year gate numericals too. Now in this particular session, our objective is to understand one more important topic from network theory, and that is the concept of mesh and super mesh. But before that, let us try to solve some more numerical which were asked in previous gate, based on the topic which we have covered so far in this particular course. And then once we have done with that, we will continue with our syllabus. That means we are going to discuss in today's session what exactly the mesh is, and what is the concept of super mesh, and how to solve numerical on mesh and super mesh analysis. So let us begin with our today's session. Let us try to solve this numerical. In this numerical, we have a circuit, something like this. We have a resistor, and this is again we have a resistor like this. Let us consider that the value of this resistor is say 2 ohm, and here the value is 1 ohm, and the circuit is something like this. Again we have 2 ohm, and then here we have 1 ohm. Again we have 2 ohm, and we have 1 ohm. In the same way, the circuit keeps on repeating up to infinite. The circuit is something like this. Up to infinite, the circuit is completely goes on increasing. And here uh, we have RA, which indicate the effective resistance across these two terminal. So this is circuit A. In the same way, here we have another circuit like this, a resistor, and here we have one more resistor like this. Then again one more resistor over here, followed by again same structure keeps on repeating like this, and it goes up to infinite. Now what are the values for these resistors? Here the value is 2 ohm, and here the value is 1 ohm. So here the value is 1 ohm, here the value is 2, here the value is 1, and so on. and the equivalent resistance across these two terminals is indicated by symbol RB. So this is circuit B. And in this case, we have some options. Basically, this question was asked in GATE 2016 for 1 mark. And our objective is, we have some options and we have to take the most appropriate answer for the question. And the options are, we have to calculate the value of RA and RB, and we need to select the most appropriate answer. And the options are, first one is RA equals to RB. Second option is RA and RB are nothing but same and both the values are going to be 0. Third option is RA is more than RB, and fourth option is RB is more than RA. So this was the question asked in GATE 2016 for 1 mark, where we have two circuits, circuit A and circuit B, and our objective is to find the effective resistance of both the circuit, and then we need to take the most appropriate answer out of these four options. So how to solve this numerical? The thing is that in this case, we have to find the effective resistance of the circuit given to us. So how to solve this numerical? See, if you see the structures, both the structures are of the kind infinite type. That means the structure is continue to repeat in the infinite sense. So how to solve this particular numerical? Now see here, while solving these type of numerical, the thing is that here we need to apply the concept of symmetricity. See, if you divide this structure into two sections like this, and if you see this particular structure from this side, it is exactly going to be equal to the structure which we have originally with us. See, originally we have first 2 ohm resistors followed by 1. In the same way, here we have 2 ohm resistors followed by 1, and the same circuit is completely repeated through infinite. That means this particular structure I can replace as RA. This is very important. So if you apply this particular logic, I can redraw this circuit. So while redrawing this circuit, I can represent this as a resistor. Then here we have again one more resistor, and then we have a circuit, or you can say a network, which is represented by a resistor, and the value of this resistor is going to be equal to RA. That means this entire network. And initially this particular point is nothing but the RA. I hope this point is clear to everyone. So this is 2 and this is going to be 1. And in this case, our objective is to find the value of RA. Now it is very simple for us to solve this numerical. See, now in this case, we have two resistors. First one is 1 ohm, second one is RA, and both are connected in parallel. So we can find first the parallel equivalent of these two, and then the equivalent of that is going to be in series with this 2 ohm resistor. So how to find RA? So I can write here as RA, which is nothing but this resistor, is going to be equal to this 2 plus. Why need to write plus? Because this and the equivalent of these two are in series, and I told you that when we have two or more than two resistors connected in series, they are simply going to add up. So here we have a parallel combination of 1 in or with respect to RA. So when two resistors are connected in parallel, what we need to do, we need to first take their product and then divide them by their addition. So I can write here as 1 into RA whole divided by 1 plus RA. This is very important. Or I can simply write this as 2 plus RA whole divided by 1 plus RA. And this is going to be equal to RA. Now what we need to do, we have to solve this equation with respect to RA. So once we solve this equation with respect to RA, we will get some quadratic equations and then use calculator to find the value of RA. The thing is that here we need to multiply LHS RHS by RA. So the movement, or you can multiplied this by RA plus 1, because in the denominator we have 1 plus RA. So if you do that, you will get here as 2 plus 2 times of RA plus this 1 plus RA, and that 1 plus RA is going to be cancelled. So here we have RA, which is going to be equal to, now this RA is going to be multiplied by RA plus 1. So here we are going to have RA square plus RA. Now if you further solve this, you will have RA square, then this 2RA is shifted on right hand side, so it will be minus RA, or simply you can cut them because these RA and RA will get cancelled. So here we have minus 2 times of RA minus 2, it is going to be equal to 0. I hope this is clear to everyone. So finally we got the quadratic equation like this: RA square minus 2RA minus 2, which is going to be equal to 0. Now take calculator and try to solve this particular equation for RA. Because it is RA square, that means we are going to have two values for RA. So if you solve, you will get one value of RA as plus 2.73 ohm, and second value of RA is going to be like minus 0.73 ohm. And because this is a physical network, that's why it is not possible to have an element which will offer negative value of resistance, so we can ignore this particular value. So finally we conclude that the value of RA for this particular network is going to be plus 2.73 ohm. I hope this is clear to everyone. Now let us try to solve this particular numerical. Again, apply the same logic. Apply the logic of symmetricity over here. That means if you cut this particular network from this particular point, so this section is exactly going to be the same what we have previously. So I can replace this particular section by RB. So if you apply that logic and redraw the circuit, we can have a structure like this. So here we have a resistor of value 1 ohm. Then somewhere over here we have again a resistor of value 2 ohm, and this particular configuration is going to be replaced by the resistor which is nothing but RB. And here we have effective resistor indicated by symbol again RB. This is very important. Now once you have this reduced form of circuit, then it is very simple to solve this. See, in this case these two resistors are now in series configuration, and that effective resistance is going to be in parallel with 1. So I can write here as RB, which is nothing but this resistor is going to be equal to 1 in parallel with series combination of these two. And the series combination of these two is nothing but we need to add them. So it is going to be 2 plus RB. That's it. Now we have two resistors and they are connected in parallel configuration. So what will be the equivalent resistance? It is simply product by sum. So it is going to be 1 into 2 plus RB whole divided by 1 plus 2 plus RB. So if you further solve this, you will get here as 2 plus RB whole divided by 3 plus RB, and on left hand side we have RB. Now if you solve this for RB, so I can write here as 3RB plus RB square, which is going to be equal to 2 plus RB. Or if you further solve this, you will get RB square minus, or you can say plus, because if you shift this plus RB on left hand side, it will be minus. So 3 minus 1, which is going to be 2. So it is going to be 2RB minus 2, exactly going to be equal to 0. So this is the quadratic equation which we need to solve now in order to find the value of this RB. So if you solve this, you will get again two values for RB. take calculator and solve this. You will get first value of RB as plus 0.73 ohm, and the second value of RB you will get as minus 2.73 ohm, minus 2.73 ohm. And again apply the same logic, because it is a physical network, it is not possible to have resistors of negative value, so we need to ignore this. So finally we conclude that for this particular network, the value of effective resistance, which is nothing but RB, is plus 0.73. Now we need to tick the appropriate answer. Now see here, we got the value of RA as plus 2.73 and the value of RB as plus 0.73. So if you compare the magnitude of RA and RB, we can easily conclude that the magnitude of RA is more than magnitude of RB. So finally, which one is the most appropriate answer or correct answer for this question? Option 3, where RA is plus 2.73 and RB is plus 0.73. So the most appropriate answer for this particular question is RA is more than RB. So in this way, we can solve this particular numerical which was asked in GATE 2016 for 1 mark, which is very, very important. In the same way, let us try to solve one more numerical, again from previous year GATE, and let us try to see whether you are capable to solve that numerical or not. So the structure is something like this. This was the questions again asked in GATE 2016 for 1 mark, and the structure is something like this. So here we have a active element of value 10 volt. Then here we have a passive element which is nothing but resistor of value 2 ohm, and somewhere over here we have again active element of value 5 ampere, and the circuit is something like this. And in this case, our objective is to find what will be the voltage that will be developed across this 5 ampere current source. So this plus minus V is our objective to calculate. So how to calculate this? It is again very simple numerical. The thing is that in order to solve this numerical, here we need to apply the concept of um, Kirchhoff's voltage law, or you can say law of conservation of energy. Now see here in this circuit, because we have two active element, first one is a voltage source of value 10 volt and another one is a current source of value 5 ampere, and because all are connected in a closed configuration, so I can say that they all are connected in a series configuration, and in series configuration the value of current will remain the same. And here this current source is capable to deliver 5 ampere of current. That means this 5 ampere is going to be the current which is flowing through the entire circuit, that too in anti-clockwise direction. So we need to take the value of current which is flowing through the circuit as 5 ampere, which is in anti-clockwise direction. The moment we take this value of current in the circuit in anti-clockwise direction, here we have a positive sign and here we need to have a negative sign. Why? Because current always flows from higher potential to lower potential. So in case of resistor, if a current is flows like this, so this is going to be plus and this is going to be minus. And suppose if you're interested to find out what will be the value of voltage which is going to be developed across this particular resistor, it is simply the product of I into R. So I is 5 and R is 2. So 5 into 2, it is going to be 10. Now we need to apply Kirchhoff's voltage law. So while applying Kirchhoff's voltage law, what we need to do? We have to read the circuit either in the clockwise direction or in the anti-clockwise direction. Now suppose I am reading this particular circuit in say anti-clockwise direction, that means in the direction of current which is flowing in the circuit, then what will happen? So first, when we are passing through this active element of 5 ampere current source, because we know that across this particular current source there will be a voltage of polarity minus plus, and we are moving in this particular direction. So basically we are moving in upward direction from negative to positive, so we are going to experience a rise. So this is going to be plus V. Let me change the color. Yeah, so this is going to be plus V, because we are experiencing a voltage rise negative to positive. And then when we are moving through this particular resistors from right to left, that means from plus to minus, so we are basically experiencing a voltage drop. So drop, that's why it has to be negative. And what will the magnitude of that voltage? It is simply 5 into 2, which is going to be equal to 10. And then when we are moving through this particular element, so basically we are moving from plus to minus, again we are experiencing a voltage drop. So according to my sign convention, a drop is nothing but minus 10, and this is going to be equal to 0. So I can write here as V minus minus of minus 10, which is nothing but minus 20, going to be equal to 0. And finally we can write V is going to be equal to 20 volt. So this is what our answer is, because what is V? V is simply the voltage across this particular active element, and that we have to calculate. So the answer for this particular question is voltage developed across 5 ampere current source in this particular circuit is plus 20 volt. I hope this is clear to everyone. Now let us try to solve one more numerical, again from previous year gate. And this particular numerical was asked in gate 2015 for 2 marks. And let us see whether you are capable to solve this numerical or not. So this question was asked in gate 2015 for 1 mark. And the structure for the numerical is something like this. So here we have a network, which is network 1, and somewhere over here we have another network, say network 2, and in between these two network we have connected some kind of active and passive elements. So first we have connected a passive element, which is nothing but resistor, and the value of this resistor is 3 ohm. And across this resistors we have a voltage developed of magnitude 6 volt, and the polarity is minus to plus. In the same way, somewhere over here we have connected another resistor in between network 1 and 2, and the value of that resistor is 2 ohm, and the voltage developed across this resistor is 2 volt. And then we have connected a active element, which is a voltage source plus minus, and the magnitude is 5 volt between first and second network. So this is what the structure given to us, and our objective in this particular question is to find the power supply by 5 volt voltage source. This we need to calculate. That means how much amount of power is supplied by this 5 volt voltage source when it is connected in this particular circuit configuration. So how to solve this? Remember one thing, I told you that in order to calculate the value of power, we have uh, 3 different formulas. And what are those formulas? First one is power is simply the product of V into I. So in order to calculate the value of power which is supplied by this voltage source of magnitude 5 volt, so we know the value of V. The thing is that in order to calculate the value of P, we have to calculate how much amount of current is supplied by this particular voltage source. So once we know the value of I, simply we need to take the multiplication of V with respect to I. We can calculate the value of P, which is in watt. So this is what the objective is. In the same way, we have another formula to calculate the value of power, which is nothing but I square into R, or we can also write this particular formula as V square divided by R. Now, based on these three formulas, as I told you that in this particular case, we are going to apply this logic, because in order to calculate the value of power through this equation or through this equation, we should know what is the value of this R, where this R is going to be the internal resistance of this particular voltage source. But in this numerical, as the internal resistance is not known to us, that's why we can treat this as not applicable for this particular case. So objective is to calculate the value of power, we are going to use this particular formula, which is P equals to V into I. Now, how to calculate the value of current which is supplied by this voltage source? Now see here. First of all, we are going to calculate what will the value of current flowing through resistor R3 and what will the value of current flowing through resistor R2. Now see here, because both the elements are passive, and I told you that in case of passive element, current always enter through positive terminal. For example, if this is plus and this is minus, and we just want to find out whether this particular element is active or passive, just have a keen attention about the direction of current flowing through this particular active element or a passive element. For example, if a current is entering in that element through a positive polarity, then this particular element we are going to treat as a passive element. Very, very important, because passive elements never supply current or never supply energy. That's why current is always going to enter through a positive terminal. For example, if we have an element with a polarity say plus and here minus, and suppose we need to identify that whether this particular element is active or passive, just focus on the value of current and the direction of current, not value but the direction. If the current is leaving through positive terminal of that particular element, then that element we are going to treat as an active element. This is very important, and the same point we have already discussed in our previous session. So the same logic we need to apply over here, because we know that this is a passive element, and that too fixed polarities of voltage which is developed across this element are known to us. So this is plus and this is say minus. So but obviously, if we want to find out what will the magnitude of current flowing through this particular resistor, that means the current flowing through 3 ohm resistor is simply the application of Ohm's law, which is going to be equal to V by R. So what is the value of V across 3 ohm resistor? It is nothing but 6 divided by R, and in this case R is nothing but 3. So answer is going to be 2 ampere. So this is the magnitude. Now let us try to discuss what will be the direction. Because it is a passive element, now what will happen? The current is going to enter through the positive terminal. So the direction of current must be like this. It is going to enter through a positive terminal. And what will be the magnitude of that current? It is going to be equal to 2 ampere. I hope this is clear to everyone. And because this is the basic uh, philosophy while solving this type of numerical, the thing is that we have to find the value of current, and then based on that we are going to find out what will be the equivalent current flowing through 5-volt voltage source. And once we know the value of V, we have the value of R, I, simply multiply them, you will get the answer of P. So this is clear to everyone, I hope. Now in the same way, apply the same logic and try to find out what will be the magnitude of current flowing through this 2 ohm resistor. So I'm writing over here. So current flowing through 2 ohm resistor is simply V by R. So in this case, V is nothing but 2 and R is nothing but 2. So it is going to be equal to 1 ampere. Now let us try to discuss what will be the direction for this. So here, because it is a resistor, so basically it is nothing but a passive element. And I told you that in case of passive, current is always entering through positive terminal. So in this case, the current has to be in this direction. And what will be the magnitude of this current? It is going to be equal to what? 1 ampere. This is very important. Now Once you have the value of current flowing through resistor 3 and resistor 2, now let us try to see this particular network. Now see here, let us treat this particular network as a junction, because whatever the current which is going in the circuit, the same current is going to out. That means here we need to apply the law of conservation of charge, or you can say simply Kirchhoff's current law. So if you treat this particular network as a junction, so here at this junction we have three terminal, or three you can say branches. At one branch we are having incoming current of 2 ampere, and then from another branch we are having outgoing current of 1 ampere. And if you apply law of conservation of charge, or law of conservation of or you can say Kirchhoff's current law over here, so if you treat this as an incoming current of magnitude 2 ampere, this is going to be the outgoing current of magnitude 1 ampere. So if you apply Kirchhoff's current law here, the value of current flowing through this particular circuit must be 1 ampere, because total incoming current is always going to be outgoing current. So here the net incoming current is 2, out of which 1 ampere is flowing through this branch. So but obviously the remaining 1 ampere has to flow through this particular branch only. I hope this is clear to everyone. Now, once you know that 1 ampere is flowing through this particular path, now we can easily find out what will be the value of power which is going to be supplied by this active source. Now, see, because it is an active element, that's why the value of current is leaving out from positive terminal. This is very important. Now, we know that the value of this I is 1 ampere. Now we need to apply simply a mathematical formula. Power which is supplied by 5-volt voltage source is going to be equal to V into I, where V is 5 and what is the value of I? It is going to be 1. So this is going to be 5 watt. This is very important. I hope this is clear to everyone. The thing is that here we have applied Kirchhoff's current law by taking incoming current is going to be equals to outgoing current. So here incoming current is 2, which is going to be equal to outgoing current, which is nothing but 1, plus the current flowing through 5-volt voltage source. So I can simply solve this. We will get the value of I flowing through 5-volt voltage source is 2 minus 1, which is going to be equal to 1 ampere. So in this way, you can solve this numerical, which was asked in GATE 2015 for 1 mark. And let me give you one numerical for homework. You can try to solve this and check whether you are capable to get the answer for this numerical or not. The circuit for this numerical is something like this. In this case, we have a circuit like this. This is going to be plus, this is going to be minus, and here we have a resistor of value 2 ohm, and to this resistor we have a voltage indicated by symbol V naught, and again we have a resistor, and then we have a dependent source over here, something like this, and then again we have one more resistor of value 5 ohm. This is of 2 ohm, and then we have a, a current source of magnitude 5 ampere, and the magnitude for this resistor is 10 ohm, and this dependent source is a current source, and the value is K times V naught. So basically it is nothing but a voltage controlled current source, because here K is a parameter. K is simply a parameter whose value is positive. This is also given in the numerical. And V naught is simply the voltage which is developed across this 2 ohm resistor. So the value of this current source is controlled by V naught. That's why it is a voltage controlled current source. And the circuit is closed like this. And here the value of this voltage source is 4 volt. Yeah, this question was asked in GATE 2015 for 2 marks. And here the objective is we have to find the value of this k, which is a parameter, and the value must be a positive one. And in the numerical, it is given that the power which is developed across a 2 ohm resistor, which is nothing but this one, or you can say power dissipated by this particular 2 ohm resistor, is 12.5 watt. So this information is given to us. We have also known that k is nothing but a parameter whose value is going to be a positive one. So while knowing this circuit, while knowing these information, your objective is to find the value of this k. What will be the value of this k? Let us try to solve this numerical, and please check whether you are capable to solve this. I will tell you directly the answer for this. The answer for the k is 0.5. If you solve this numerical, the thing is that you need to apply the logic of KVL KCL over here to solve this numerical, and if you apply that logic properly, you will get the value of k as 0.5. The thing is that in this case, the power developed across 2 ohm resistor is known to us, which is nothing but 12.5 watt. And we have this V naught, which is nothing but the voltage across this resistor. So the thing is that first of all, calculate the value of this V naught by using the formula P equals to V square by R. So P is known to us, R is known to us. First of all, find out the value of V naught. Once you know the value of V naught, then try to apply some KVL KCL over here and find the value of this K. So this is the hint to solve this numerical. Now let us discuss the concept of mesh analysis, or what exactly mesh analysis is. And then we are also going to discuss about the concept of super mesh. So what is mesh? In the last lecture, I already told you that mesh is nothing but a smallest closed path which is available in a circuit which cannot be further classified. So those smallest closed path are nothing but mesh. And while solving mesh, or sometimes this is also called as mesh analysis technique, here we need to apply the principle of law of conservation of energy, or simply you can say that we need to apply the concept of Kirchhoff's voltage law. This is very important. Now, because we need to apply law of conservation of energy or Kirchhoff's voltage law, it is our prime duty that if we have a network and we want to solve that network through mesh analysis technique, or say mesh domain analysis, then in that case, if in that particular network we have an active element, that active element must be of the kind voltage source. That means आप ये टेक्निक तभी अप्लाई कर पाएंगे जब आपके सर्क्यूट में सारे के सारे जो एक्टिव एलिमेंट है वो वोल्टेज सोर्स होने चाहिए. If you have a network in which you have a current source instead of a voltage source, and your objective is to solve that particular network through mesh analysis, so first of all, what we need to do, convert that current source into equivalent voltage source, and then apply Kirchhoff's voltage law by applying a proper sign convention, like voltage drop is negative, voltage rise is positive. You will get some equations in terms of current. Solve those equations, you will get the value of I followed by V. So that is what the basic concept behind mesh analysis. So let us try to solve one numerical so that you can understand what exactly mesh analysis is. And for that, I'm taking a simple uh, network over here. Suppose here we have a network, something like this. So we have an active element, plus minus. So this is plus and this is minus. And here we have a resistor of value 1 ohm, followed by, here we have again an active element which is of voltage, and Here we have a resistor and then again one more resistor. The value for this active element or voltage source is 10 volt, and here the value is 5 volt, and here the resistor is 2 ohm, and here the resistor is 3 ohm. And our objective is we have to solve the value of P, which is nothing but the voltage developed across 3 ohm resistor using mesh analysis technique. So how to solve this? So while solving this, first of all, we need to identify how many number of active elements are available in the circuit. So here we have two active elements. First one is a voltage source and second one is another voltage source. That means we can easily apply mesh analysis over here, or you can say Kirchhoff's voltage law over here to solve this particular numerical. So while solving this numerical, what we need to do, first of all, we need to assume the value of current flowing through this particular circuit. So I'm considering that. Let's consider the value of current flowing through first mesh is I1 in clockwise direction, and the value of current flowing through the second mesh is I2, which is again in clockwise direction. It may possible that someone may take the direction of current in anti-clockwise direction, like current 1 is in anti-clockwise or current 2 is in anti-clockwise, or it may possible that someone may take current I1 in clock and current I2 in anti-clock, or vice versa. The thing is that depending upon your requirement, just take the value of current either flowing in clockwise direction or they are flowing in anti-clockwise direction. The thing is that based on your uh, assumption, whether you are reading that particular circuit in clockwise or in anti-clockwise, you will have some set of mathematical equations, and then you have to solve those mathematical equations to find the value of I1 and I2. And if your conventions are correct, you will get the value of I1 and I2 are positive. And suppose you will get the value as negative, that means whatever the current which you have assumed, that is not the actual direction of current flowing through the circuit. The direction is exactly ulta or opposite. For example, in this case, I have assumed that the value of current flowing through mesh 1 is I1, which is in clock, and mesh 2 is I2, which is again in clock. And suppose if I solve this particular set of mathematical equations, and if I got the value of I1 and I2 as positive, that means whatever the direction of current which I have assumed over here are nothing but same. If I got I1 as positive but I2 as negative, that means I1 is flowing in clockwise, but I2 is flowing in anti-clockwise because I got the value of I2 as negative. In the same way, if I got I1 as negative and I2 as positive, that means I1 is in anti-clockwise whereas I2 is in clockwise. Or it may possible that I may get the value of I1 and I2 both are negative. That means the actual direction of current flowing through this mesh are anti-clockwise. I1 is again anti-clockwise, I2 is again going to be anti-clockwise. So this is what the basic sense while solving the mesh analysis. Now what we need to do, we have to apply law of conservation of energy in both the meshes. So in this particular circuit, we have two mesh. This is your first closed path and this will be your second closed path. So while writing KVL in first mesh, so I'm writing here, apply Kirchhoff's voltage law in first mesh, which is say A, this is say B, this point is a C, this point is a D, this point is a E, and this point is a F. So first mesh will be starting with A, then B, then we have E, and then F, and then coming back to A, like this. A, B, E, F, and then coming back to A. And in this particular mesh, I'm reading this particular circuit in the direction of current. So the moment we read the circuit in the direction of current, again here we need to apply the concept of voltage drop or voltage rise. This is very important. And according to my sign convention, voltage drop are negative. That means when we are moving in the direction of current, that means from plus to minus, we will experience a drop. And when we are moving in the opposite direction of current, that means from negative to positive, we will experience a voltage rise. This is very important. So apply that logic. So first, when we are moving through this particular element in clockwise direction, negative to positive, we will experience a rise. So this is going to be plus 10. Then when we are moving through this particular element, because the current is flowing in clockwise, so this plus and this is going to be minus. So when we are moving in the direction of current, we will experience a voltage drop, and the drop is minus I1 into 1, where this 1 indicate the ohmic value of this particular resistor. In the same way, when we are moving through this particular element, basically we are moving from plus to minus, so we will experience a drop, higher to lower, of magnitude 5 volts, so minus 5, and then this is going to be equal to 0. I hope this is clear to everyone. Now once you know this, we can easily find out the value of I1. So I1 is going to be equal to what? 10 minus 5, which is going to be 5 ampere. So this is first answer. Now in the same way, apply Kirchhoff's voltage law to the second mesh, which is nothing but B, C, D, E, B. This one, B, C, D, E, B. Let us try to move or trace the circuit again in clockwise direction. What will happen? See, when we are moving through this particular element, basically we are moving from negative to positive. That means we are going to experience voltage rise. So this is going to be plus 5. Then if we are moving from this particular resistor, because the current which I have assumed initially is flowing in clockwise, that's why this terminal is going to be plus and this terminal is going to be minus. So we are moving in the direction of current. That means from plus to minus. So higher to lower, we will experience a drop. So this is going to be minus. And what will be the magnitude for that drop? It is going to be 2 into I2. And then when we are moving through this particular element, again we have a drop, because this is plus and this is going to be minus, and we are moving in the direction of current too. So this is going to be minus, and what will be the magnitude for that drop? It is simply 3 into I2, because these two resistors are connected in series, so I2 is flowing through 2 as well as through 3 ohm resistor, and this is going to be equal to 0. So if you solve this, you will get the value of I2 as 1 ampere, and that too positive. See here, I1 we got plus 5 ampere, I2 we got plus 1 ampere. Because we got both the value are positive, that means whatever the direction of current which we assume initially, in mesh 1 I1 in clock, in mesh 2 I2 in clock, both are correct. This is very important. Now once you know the value of I1, once you know the value of I2, you can easily solve this. Now our objective is to find the value of V. So V is simply the voltage which is developed across 3 ohm resistor. So apply Ohm's law. So V is going to be equal to what? I into R. So in this case, what is I? Is I2, and what is R? It is nothing but 3, and we know the value of I2 as 1. So 1 into 3, it is going to be equal to what? 3 volt. So the answer is voltage developed across this 3 ohm resistor is 3 volt. I hope this is clear to everyone, and this is what the concept of mesh analysis. Now let us try to discuss what exactly super mesh is. Concept of super mesh. Super mesh. Super mesh means what? Again, a kind of a circuit where we have more than two mesh, and while solving those particular circuit, if we have a common current source, this is very important. If we have a common current source between two meshes, two mesh, then that structure we are going to treat as a super mesh. Now let me explain you via circuit. Suppose we have a circuit like this. Here we have a active element of voltage, and let's consider that the magnitude is 10 volt, and here we have a resistor of value say 2 ohm, and here we have a current source of magnitude say 1 ampere. 1 ampere. and then here we have a resistor of value say 2 ohm, and again here we have a resistor of value say 1 ohm, and then the circuit is something like this. Now this is the example for super mesh. Now why it is called a super mesh? Because in this case we have total two mesh. For example, if you apply that logic, see, if you want to calculate how many number of mesh are there, so m is going to be 2. Why 2? Because here we have two closed path which cannot be further divided into sub closed path. This one will be your first closed path, and this one will be your second closed path. You may take this entire term as a closed path, but this is not considered to be a mesh because it has two further sub closed path in it. So what is mesh? Mesh is the smallest closed path. So here we have two. Or you can find out this by apply that logic. Mesh is nothing but branch minus node plus 1. You will get the answer as 2. Let us try to find out how many number of branches are there. So here we have uh, 1, 1, 2, 3, 4, and 5. 5 element, that means branches are 5. Minus, let us try to find out how many number of nodes are there. So nodes are, this is going to be 1, first node, then this is going to be second node, this is going to be the third node, and this entire one is going to be the fifth node. Sorry, fourth node. 1, 2, 3, and 4. So here we have 4 node. So n is going to be 4. And then here we have plus. So 5 minus 4 is 1. 1 plus 1 is going to be 2. See, we got the same value. So in this way, we need to identify how many number of branches, how many number of nodes are there, and based on that we can calculate how many number of mesh has to be there in that particular circuit. So you can apply this logic, or you can apply direct observation technique to find out the mesh available in the circuit. Now how to solve this numerical? Because it is a super mesh, so you cannot apply Kirchhoff's voltage law over here directly, because if you try to apply Kirchhoff's voltage law in the first mesh, you can easily find out what will the value of voltage across this. You can easily find out what will the value of voltage across this. But it is not possible to find out what will the value of voltage which is going to be developed across this, because we don't know what is the internal resistance of this particular current source. In the same way, if you apply Kirchhoff's voltage law in mesh 2, again we can write the voltage developed across R2 and across 2 ohm resistor and 1 ohm resistor easily, but it is not possible to find out what will be the value of voltage which is going to be developed across this particular active element, because we don't know the internal resistance. Hence, while solving mesh analysis, we have to use a combination of KVL and KCL both. This is very important. So how to solve this? For example, again we need to apply the same logic. Let us consider that the value of current flowing through first circuit or first mesh is say I1, which is in clockwise. And let us consider that the value of current flowing through mesh 2 is say I2, which is again in clockwise direction. So what we need to do, first of all, we are going to write the correlationship between I1 and I2 by taking a common branch in between two mesh. So here, if you look at this particular structure, here we have an active element of current source 1 ampere, and this particular side we have mesh 1, and this particular side we have mesh 2. Now see here, in this particular circuit, in mesh 1 we have assumed that the value of current flowing through mesh 1 is clockwise. So with respect to this particular active element, the direction of current I1 is in downward. In the same way, with respect to mesh 2, we have assumed that the current is in again clockwise. So with respect to this active element, the direction of current flowing through mesh 2 is I2, which is in upward direction. So I can write this equation as I2 minus I1 going to be equal to 1, where I2 is in this direction, I1 is in this direction, which net is going to be equal to 1. So here I have assumed that the upward direction is positive, downward is going to be negative, and the effective upward is going to be 1. So I can write here as I2 minus I1 going to be equal to 1. So this will be your first equation that we have obtained while applying Kirchhoff's current law. or simply the resultant of current which is supposed to be flow through this particular active element. I hope this is clear to everyone. So once you know this, then we need to write another mathematical equation, because here we have two currents. So but obviously in order to solve these two currents, we must have another equation in terms of I1 and I2 to solve this particular numerical. So what we need to do now, we need to ignore this particular active source, and we need to club these two meshes simultaneously. So if you ignore this, what we can do, we will just remove this. Let us assume that कि यहाँ कुछ है ही नहीं. Just remove this and then apply a logic by considering that this is going to be the entire single mesh, and then apply Kirchhoff's current law over here. Sorry, Kirchhoff's voltage law over here. So if you write Kirchhoff's voltage law by considering this as an entire mesh, this mesh is called a super mesh, because in this case we have clubbed two meshes simultaneously. Now this is going to be a super mesh, and then apply Kirchhoff's voltage law over here. So if you apply Kirchhoff's voltage law over here by assuming a proper sign convention like voltage drop is negative and voltage rise as positive. So I'm reading this circuit in clockwise direction, that means in the direction of current. So when we are moving through this particular element, we are basically experiencing a voltage rise. So this is going to be plus 10. Then when we are moving through this particular resistor, so current is in clock, we are again moving in the clock, so it is going to be drop, so minus 2 into I1. Then when we are moving through this, again we are moving in the direction of current, so we are going to experience a drop, so minus 2 into I2. And through this again we are going to experience a drop, which is nothing but minus 1 into I2. This is going to be equal to 0. If you solve this and rearrange the term, you will get here 2, or you can say minus 2I1 minus 3I2 is going to be equals to what? Minus 10, and multiply both sides by negative, so you will get 2I1 plus 3I2 going to be equal to 10. So let this will be your equation number 2. Now we have two equations. First one is this, which is nothing but I2 minus I1 equals to 1, or you can write this as minus I1 plus I2 going to be equal to 1. And second equation is this. Take calculator, solve this equation, and please write the answers for this particular numerical, what you got the value of I1 and what you got the value of I2. Now suppose if you got I1, I2 both are positive, that means whatever the direction which we have assumed previously are nothing but same. If you got I1 as positive and I2 as negative, uh, the value of current flowing through mesh 1 is correct, which is clockwise, but the value of current flowing through mesh 2 is incorrect, which is exactly anti-clockwise, but we have assumed that it is clockwise. In the same way, if you got the value of I1 and I2 as negative, both negative, that means initially whatever the assumptions we have taken that both the currents are flowing in clockwise, they are not correct. Both the currents are actually flowing in anti-clockwise direction. So in this way, you can apply the logic of mesh analysis and super mesh concept to solve a given circuit. The thing is that in case of super mesh, how to identify whether that particular numerical is of the category super mesh or not? Just see whether we have a common current source in between two mesh. If we have a common current source in between two mesh, then in that case it is not possible to solve that numerical through apply only Kirchhoff's voltage law. In that case we need to go for a combination of KVL as well as KCL. So first of all, find out what will be the relationship between current flowing through both the meshes by applying this logic, and then ignore that particular active element which is in common between those two mesh, club those two mesh, form super mesh, and then apply law of conservation of energy, which is nothing but Kirchhoff's voltage law, to find out one more mathematical equation. Then you have two set of mathematical equations, solve them, find out the value of I1, I2, and based on the magnitude as well as nature, we can find out their actual direction. I hope this is clear to everyone. So in the next lecture, we are going to solve some numerical on this, and we will continue with our syllabus by understanding another concept of network analysis, that is nothing but the concept of node analysis followed by super node technique. Thank you.